Okay, hi, my name is Pablo Tesone. I have been already here. In this talk, this idea for today is that we are going to talk about Git. We are going to present with Guille. The idea is that we want to cover the questions that are more common. If you have doubts, in the second part, we will start with a little presentation, a little background of some concept. But later, the idea is to have an open talk and talk about and try to explain different problems and listen your pain and explaining how to handle it, because Git is a really powerful tool. But as we are going to see, it has many ways of being used. It can give us nice results, but also it can explode miserably. So, why we are talking about using Git and we don't use a custom solution that fits better for our small talk like and be more close to the concept that we have? Well, because the first one is that give us visibility, that give us the ability to interact with people from other communities that I already know how to use Git, how to handle. They can find us. It's good, for example, to be in GitLab or in GitHub or in any public repository. You can easily share the same space with existing other projects. There is a lot of existing tools to handle Git, and also because when we have our project, it's not only a small talk code, it's not only Faro code that we want to handle, but also we want to handle resources from images to text files or different elements, and we want to handle it in a really good way. And Git has really good support for handling all this. It's well taught. It's a really good tool, but it's a really, in a side, it's a really powerful tool, but in the other side, it's a dangerous tool. So they are giving us a big gun, and we have to use it correctly. So when we talk about Git, there is a problem, is that we consider all the time that we all know Git, that we are the masters of, we understand all the concepts. And the first thing that we have to really be sure when we use Git, as any other powerful tool, we were talking yesterday about a metaphor. I would say, well, Git is like the assembler of the machine code of the versioning system. You can do whatever, but you have to know a lot of details, a lot of things, or you keep in your little world and do always the same path that you know that it works. So when we are using Git, we really have to think where we are. We are a newbie that just do a little path, and if it works, it works. We are great, and when it does not work, we have to restart, I don't know, delete the project and resave it again, and that happens a lot, and it's a good way of solving it. We are a little more smarter, and we can find solutions, and we take solutions everywhere, or really we are the one that knows and understands all the beginning. This is a process. We to know where we are. That is the important part. If we are a newbie, we will learn little by little, step by step. If we are a person that knows all the inter details and mostly is a contributor to Git, you can help others. But we have to know where we are and try to learn every day a little more. So, first, a little question. How do you clean your working copy? This is completely outside Faro, Smalltalk, whatever. You have a repository in Git that you have modified the files directly or not, but they are modified in disk, and you want to clean and recover it to the version that is in the repository, the committed version. Let's say, I have broken everything, I want to return to the committed version. Yeah? Questions? Yes, you have the USB with Ubuntu and reinstall. Yes.
I mean, two ways.
Two ways.
Two ways. If I'm not fully sure, I need something off that later.
Mhm.
So I did stash.
Okay, that
Because that moves the dirty stash out in.
I will hold it in my finger. That go.
And the other one is git reset dash dash hard head.
I like because here we have yes another point. Yes.
If you've just got a few files, you can do git check out dash dash slash file name.
Okay, I like it. I like it because we started having first. I say a simple operation. I ask a simple operation. I want to return to the committed version. How I done? And when we started seeing, we can see them as well. We look for in Google, and we found two answers in any blog, and we found two answers that might not might work. But the first answer already started adding me another concept. That is important, that say, oh, you stash or no stash, and two ways of doing the same solution. One that we are saying is, well, the reset, that this will reset your index. We don't know what is the index, we are going to come. But this is not quite what we want, but we have the solution similar of what Norbert was proposing, that, okay, it will reset and will clean the working copy, but will not remove the untracked files. If we have files that we created or not, we have to know what to do with them. So basically, the way of cleaning is this. So see how important note about this is not to remember this. We can always look it for, or just as Mariano said, we remove the repository and we reclone it. But the important thing is that we have a lot of concepts in the meantime that we have to understand what we can ask Git about it.
Or we ask fatalities.
Yes.
Google.
Yes. What the problem we Git, and it's something that we do all the time, because even if you are in the really top of the stair, as I saw before, that I don't even believe myself there, because I am looking all the time at recipes in Google. So I will end doing that, and that is fine. But we need to understand some concepts behind, so we can try not to do things blindly. So. As I said before, Git is not easy. It has a lot of concepts, a lot of ideas that are present in it. For example, we talk about an index, we have a head, we have operations on this. Some of them look simpler or look similar to the ones that we have in another version control system, like commit, but the sense of commit is not the same sense in Git that we have in SVN or whatever you call your whatever other version control system. It has its own caveats, so its own differences that we have to manage. It's a really heavy command line oriented tool. We have to write nice commands. It's intended to be used like that. And there's some documentation sometimes. Is documentation. We produce the documentation ourselves, so we cannot say nothing about their documentation because ours maybe is worse. But it's incomplete, and sometimes it's ambiguous, and sometimes we fall in. As is a popular tool, we can find a lot of solutions, but in the other side, some solutions are we can doubt their quality. Why? Because, as I said, and as I saw in the example, that both solutions work and do the similar things, and they are historical difference why you can do it in one way or another, because they were added with different operations. But there are multiple workflows and multiple ways of doing the same operation. There is no one single set of operations that you can do, but you can do them with operations of more higher level that they do many things at the same time, or you can access at the lower level operations inside and do it one by one, because when you are a power user, maybe you want to do it in different steps.
And also, it's not just about the operations. So there's people that want to use Git in one way and Git in another way. So you can try to use Git as SVN, and you can try to use Git as a really distributed thing. So, and if you read a blog post, and people will say, no, this is the way to use it. Of course, everybody has their way, and actually nobody has their way to use it.
Yes. The problem with the way is that could be my way, but it's never your way.
No, it's my way.
Or the highway. Well, as Guille said, the people mix workflows, and that is when the problems start arising. When we have one single workflow and we say we work like this, this works perfect. But the problem is when now I am doing something to be centralized and then I do something more distributed, and then I do something more custom by hand. Other times I use the high-level tools, and boom, that makes is bad. And the graphical tools, they are not graphical. We cannot find, because it will be nice to find a graphical tool that we say, this has all the handle, all the complexity, all the path, all the ways. Of course, when a graphical tool or scripts or whatever that are built on top of Git, they select a workflow, and if you follow that workflow, you're cool with that, and the same will happen with any tool on top of Git. Do you want to continue?
Okay, I can.
So,
Good. So, if you want to, actually one of the main problems when using Git, and that's why people remove the repository and clone from scratch, is because there is a kind of a gap between what actually Git is doing and what people understand from Git. So the mental model that we have of what it is is not actually mapping well what is happening in reality. So I will try to explain in a couple of minutes the really key points of what makes Git Git, and like that you can try to map your mental model to what is really happening, and then like that you can try to understand better when you have an error, okay, how to fix it. So the two core concepts that you need to manage is that it's a graph. At the end, there is a graph, and all the operations that you're going to do, they are going to manipulate the graph, add edges, add new nodes, and stuff like that. And it's a two-stage database. So there is a database where we are going to store stuff in different places. So, but until we are actually doing the commit, the data we are going to store in this database is going to pass through different stages. So when I say Git is a graph, you have to think about this. So I have a pointer. No, okay. Can you pass me the pointer there? It's, well, no, I don't know where I put it. It's not a problem. Okay, so what do we see in this graph? So here, every circle is a commit. So every time that you commit, it's not that you are actually saving the full-time snapshot of the source code and store it in a zip. Actually, it's creating a node in a graph, yes? That says, okay, this is the latest things that you did. So the changes are stored inside each node. And what do these nodes do? What do they know? So they are actually related to each other by the parenthood, yeah? So this dashed line. So that means that each commit will know its previous commits, yeah? So like that, if we start from one commit, we can trace the history of everything that happened, yeah? So if you start from the top commit, so the time here goes from the bottom to the top. So in the bottom, we have the oldest commits, and the newest commits are on the top here. So if you start from the newest commit that is on the top, if you follow the parent relationships, you know what happened before the history, yeah? One interesting thing here is that you will see that there are some commits that have only one parent, and there are some commits that have many parents, and there are some commits that have no parent, usually the base commit that we have at the beginning of the repository, because we need to set this up. And the other kind of things that we're going to see in this graph, which is actually not in nodes, are these things that we call references, yes? And which are the, so somebody, thanks, Steph. Cool. So, where is it? Yes. Okay, so these references. So what is a reference? It's like a tag, a label. I will not call it a tag because otherwise we're getting confused. So it's a label. It's a label that you put on a commit. So here, for example, we have many different labels. So here I can label this commit as feature branch. Yeah, it's a label. You say, okay, I will put a little name to this guy, and I will name this little guy also master branch. And there are other kind of references that are kind of special labels. So this one, I created it, and this one, I created it, but this one comes with Git. It's a label also. It's a reference, but it's managed by the system. And we have this other label that is b1.0, that is a tag, which is also a kind of a special reference. Yeah, so we have different references, but all of them are actually labels to commits. Yeah, so this is the base thing. So if you understand that you have commits that have parenthood, and so they have the parent relationship, and then you have labels, that's most that you actually need to understand. So let's see what happens when you have the commit operation. Yeah, so let's start basics. So you do git commit, boom, with the message, and then actually we started the repository before. We have already an initial repository. This slide is old, so now master is not master anymore when you create a git repository. But so of course, when we create an initial repository, the commit, we have a first commit that will have some empty content. Okay, and we have a branch which is a reference. And this branch is pointing to the commit, to the current commit of that branch. And then actually this head reference is a special reference that is pointing to our current branch. It's where we are working on. Yeah? So you know that when every time that you use Git, actually when you commit in a branch. So how do you know what is the branch you are committing on? It's because it's the branch that is pointed by head. Yeah? So if you know where head points to, you know where the branch, what is the actual branch and where you are putting your commits. So if I do git commit -m with a message, what will happen is that Git will create a new commit, yeah, a new node in the graph. It will make it reference the previous commit that was pointed, and then it will update the current branch to this new commit. Yeah, so this is all that happens. Actually, there's nothing more to do to it. Yes, Nuri? Yes. 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 It can be different. We are going to see. But yes.
In this case, the time is going the other way than the arrow says, right?
The arrow, which arrow?
The one on the left.
The parent.
No, no. This is the new commit. This is the new one. This is the old one.
Go back. You see that 37 is the commit 37.
So this is 37. This is the guy. This 37 guy now is here, and I created a new commit and points to the previous that is certain. Yeah, it's difficult to show with these things. Now what happens when I do a git branch? Yeah, we want to create a new branch. Yeah, we do git branch. What happens is that we are creating a new reference, a new branch reference. That, let's say I created a branch that is called development, and then this reference is just a new label that is pointing to the current commit. How do we know what is the commit of the that we have to point to? Because actually we just follow head. We take head, we follow master, and then I found this commit, so okay, development should point to that. Yeah, that is what it does. Of course, you can then go to the fatality thing and go in GitHub in Stack Overflow and say, how can I create a branch that points to this specific commit? There are ways to bypass that stuff and do other things, but by default, Git branch will just do this. Yeah.
You can see here that what we want is create a reference to a given commit. In this case, usually we are going to do to the current commit. As Guille said, we can split the history anywhere. But the important thing here is we want to create a new arrow pointing to a commit.
Yes, and something interesting is that here I created a branch, but I didn't move to that branch. Yes, so the branch operation just creates a branch. And actually branch, again, here we are not branching history. There is no copy, there is no tree actually. Yeah, so this branch thing, this branch concept, it's actually a really bad name for something that here is, for what we have here. Because we have a graph, but there's no tree, and we don't have branches in the tree. So that's why people actually, that's one misconception following yesterday's workflow that we find here. People sometimes think that they are branching history. So they are actually making things diverge, and it's not the case. Not yet, at least. Yes? Oh, the internal representation, let's not go in there. We don't care. You have a graph. Think about that. And actually, I don't know much of the details inside. So now we created a branch. So I commit again. But actually, we didn't move head. Head was pointing to master. So now if we commit a new commit, this is DC, yes? And this guy DC, we create this DC guy with our new changes. And we move the current branch, which was the one pointed by master, by head. So head points to master. I will update master from here to there. Yeah. And development, what happens to development? Development stays in the same place it was. It was a label to this commit, so why should it move? Yeah. So again, commit, Git is kind of a contextual tool. So it has state, and this guy represents the current context. Yeah. So you are here, and every operation that you do will touch only from here unless you bypass the default. So, okay. So we committed. I don't know if you realize, but actually we have these branches, which are references, with these references, I will call them, which are references that actually can move. Yes. So when I commit, master was pointing to something, and now master points to something else. Yes. So this is a reference, but it can change what it points to. So it can move. So that will change in other kind of references. So what happens when I do, let's imagine that I have this tree because I did some stuff and I was working, yeah? So here we have, it's not a tree because it's actually pointed, so, but okay, we have this graph, yes. And so we have one branch here that is pointing to V8, it's development pointing to V8, and when I have master that is pointing to DC, and I am working currently on master, I know that because head is here. Actually, if you do a git log from the command line, Git will show you head in uppercase, yeah, so you will see it. I have this and I want to change my branch. Yes, I want to start working on the development branch because I had stuff there and I have to keep working here. So for that, we have the checkout operation. And what does the checkout operation do? It's actually as simple as this. If I want to check out the development branch, I say git checkout development. It just changes head to point to the development branch. And that's all that happens in the graph. Yes, because then we have the two-stage database that but this is all that happens. So that's something that is interesting. So check out something is just changing one reference. No, there's nothing else. So the checkout operation is saying, I want to work in this branch, just that. Now, of course, somebody probably has seen this detached head error somewhere. Yes, working in Git, and sometimes you have this, you have rejected stuff, and sometimes you have detached head. Okay, what is detached head? So actually, it's super easy to explain. It's when head doesn't point to a branch. Yeah, head is not pointing to a reference. It's pointing directly to a commit. And this could happen if we try to check out a tag. Yes, because how Git happens is that when we check out a tag, the head doesn't point to the tag. Head will point to the commit pointed by the tag. So and we are in this situation of detached head, which means that this head, not this head, yes, is not attached to a reference. Now, what happens with merge? Because merge is also something that is different from other kind of control version systems. Yes, yes. We have slides for that, but later. Well, let's go over the operations. We have this Git. Now, I wanted to just show a bit about what happens when we have a merge. Because merge is one of the most complicated things because nobody knows how to resolve conflicts. And that's why people throw away repositories. This rm minus rf, and then, yes, git clone again. Actually, git merge, what we'll do is to try to mix the changes here with these other, with the changes in here, yeah? So I am in master, that's clear because head is pointing to master, and I want to merge, to take the changes that are in development and put them here too. Yes, I want to mix these two things. I want to merge them. So, of course, conflicts aside, let's imagine that no conflicts will happen here. What will happen, respecting this graph representation, is that Git will create a new commit which has the mix of the changes. So it will, this new commit will represent the commits that come from here and come from here. That's why it has two parents. And then it will update the current branch to point to this new commit. So it's like actually we are doing a new commit, but just has two parents. Yeah. So actually it's creating a commit that has two parents and then putting that commit there, like the thing that we saw before. Of course, since this looks like a commit operation, only the current branch is moved. So it's updated. So the development branch doesn't change. So one important thing about the merge operation is that we are always merging the thing that we want to get into the current branch. Yes, so it has a direction. Yes, we are always merging this guy into this guy and not the other way around. It's not merging the branches. Branches are not merged. Actually, what happens here is that we take the changes from here and we apply them to the master branch, and development doesn't get changed. So, is this kind of clear? Yes, yes. Okay. So, sometimes you are going to do a merge and you're going to maybe get scared because you have this fast forward stuff. Yes, students get scared a lot about this. So what is this fast forward? Because actually, yes, it's strange when you try to commit and you have a log message like this. Yeah, come on. So let's imagine I have my head that points to master, and master is in this commit. So then I was working on development branch, and I did some changes. So development is in the future, so it has more changes. Yes, but here the history is linear. There was no diversions because nobody worked on master. Yes, so master stayed there. So if I try to merge development into master, we don't actually need to create a new commit that has the two parents and so on. Since there are actually no diversions in the history, we can just move master up. And actually, that's the equivalent of bringing the changes in development to master. Yeah, so and there's no conflict that could arise in this case. So that's just a fast forward. It's just that Git decided that I have a fast path here. I can do it better. So let me do it. Just that. So when you have fast forward, don't be scared. Yes, Nori?
But this is not by default.
Yes. Yes. But in my configuration, I didn't touch any default. It is so just try it. Try to simulate this graph. So it's two commits.
Not on GitHub. If you do the merge on GitHub.
Yes. In GitHub, when you merge a pull request, GitHub will enforce a normal merge. Yes. Yes. Okay.
Yes, you can, as I said before, there is many ways of doing everything. You can configure, even sometimes in the first time it asks you what do you want to do and keep that information. So you are starting with Git and started asking me how I want to work. I don't know how I want to work, but could be that you can choose to allow fast forward, that is the normal because we will not create commits empty, or always create commits empty.
There's a pull down in GitHub. You can say merge commit, squash, and there is options.
Yeah.
The merge commit is just a default on the UI.
You have different strategies to merge, though you can also choose to rebase by default. And yeah, there was a hand.
Question, I've done a lot of Git at the command line, but how do you, like I was trying to ask the person before, it's like Gemsong does have version control, obviously, for classes, and I'm wondering how, and it's a development platform, so sure, it should have version control. How do you get this command line capability, which you really need to get good Git control, into our world, which is very editor-oriented?
Okay, wait a couple of minutes. So I will go a bit faster on this, so because otherwise I don't think we are going to fit the.
No, but you see what I suggest that this is important. It could take a bit more time. Parallel with new presentation a bit later, because I think that this is important.
No, but also what we can try to do is, like, for example, we can share a notepad where everybody can actually put questions, and maybe what we can do is to go over them later offline and make small videos solving those issues. But if you have issues, we can actually maybe make videos on that, and that could be a nice thing for, like, we don't answer online here. We give you something that is persistent and that can help you fix your problems. And we create documentation at the same time. So yes, let's do that. So we have this thing that I didn't talk to you about. So that Git is also a two-stage database somehow. Yeah. So why is a database? Because first, it has some concept that come from databases. So we actually, when we want to put something inside Git, we do a commit operation. Yeah. So we are actually taking changes and storing them somewhere, and it stores history also, and we can go back. And of course, it's a special database that stores files, some other kind of stuff. But actually, you can do crazier stuff, but not from the command line in general. But I show you the view from the commit point, from the graph point of view. Yeah. But actually, every time that we do an operation, something happens in your disk too. And I didn't tell you what happens in your disk with your files. And that is actually what you care about. So for that, we need to understand that first, there are 4 main things that you can have in a Git repository, 4 main components. So first, everybody know that you have some repository that is stored in the cloud, I will say. Yes, it's another machine, like GitHub. So you have repositories that are in GitHub, in Bitbucket, I don't know, some place where we are going to hold everything and not lose it. Yeah, so I'm going to call them remotes. Yeah, and then when you clone this guy, you get a copy of that repository in your machine. So it's a distributed system. So, yes.
Not a full, it's just a clone of that thing. You don't get the whole repository, right?
You have the whole repository by default. So you can then tweak that, but yes, by default you have the whole repository with all the history and everything. It has a lot of optimizations and compression and a lot of things. Yes. Okay. I don't remember. But I am. I don't. Yes. Okay. The default values.
Yes, it gets all the commits that you need to recover your story. If you have 10 years of development, it will come with 10 years of development. Maybe the branches that are dead and they didn't continue, they will not download. But your branch that you take, if it has 10 million commits, it will download 10 million commits. If not, you can only, why? Because all the operations that it needs at the end, it needs all. If not, you are reducing what you can do.
So it takes the current branch, and from there it grabs all the commits that are referenced.
If you want to clone a whole repository, you can just copy the whole thing. It's the only way.
But in any case, big spoiler here, I am not a Git expert. So I don't know all the Git fatalities. I'm sorry for you. Every time that I need a fatality, I go to Stack Overflow. But actually what happens is that I know how to map my mental model to the fatality, so I know what I am doing. That's the only thing. But exactly what is the operation? And usually I don't care because I go to the documentation. But yes, so we clone, we get a copy, a partial copy. It could be a full copy probably if you set some flags. We can control the depth of the commits that are grabbed also. But and eventually you want the files. Give me the files, come on. And the files are this thing here that we are going to call a working copy or a working directory, yes? So which is your directory with your files, yes? Now, actually, here you have your files, but Git needs metadata to manage everything, and it needs this database with the history. So actually, there is this thing that I call the repository, which is actually the database with everything, and that is stored also in what you download. So you download your files that are actually extracted from the repository the first time that you clone. And then in the middle, there's another thing that is called an index, which is a kind of a staging area. It's hidden most of the time, so you don't care too much, except if you're doing advanced stuff. But you have to pass through this thing to actually commit. Yes? So let's revisit now the operations that we saw before on the graph to see what happens when you touch something here and you want to manipulate it. Yes? So first, commit. No, add. Okay, everybody knows that first, when you want to commit something, you need to add, and then you commit. Why do you need to do that? Well, that's because add actually takes your changes and puts those changes in the index. Yes? That's how actually Git knows what are the differences that you have. When you do Git status and you want to know the diff, actually Git compares this working copy with the index, and then when you add, you don't have any more differences. So that is the add. We have changes and we move them to the index. And now we want to commit. And when we commit, we move, actually we will package the changes that we put in the index. We will make a little package that is a circle in my graph, and we put that into the repository. Yes? So if you just add and you don't commit, things never get to the repository. Yes? So that's important. And if you commit and never add, so you never got stuff in here, so you are never getting actually anything useful in the repository either. So that's why you need to add and commit. We saw this checkout stuff that changes the graph, so it changes head. Now we change head in the repository, and after changing head, we take the new current branch, and we put everything in the index and the working copy. So you take the new versions of the files that are pointed by the new commit that you checked out. Now, there is, yes?
Also, index basically gets reset.
Yes, yes, yes. Yes, like that, because actually what we want to ensure that is that when you check out, these things are always have the same information. Yes, but we can avoid some details. So what happens when you do a fetch? So actually all the other operations that I just showed, they don't need any network thing. So that's why when people tell you, okay, yeah, you can do Git in the train without internet connection, okay, that's because committing, add commit, checkout actually happens at this level that is in your machine, and we never went anywhere else. So now when you want to fetch the things that Pablo did, yes, because Pablo told you, you look, I already fixed that bug. So, okay, we have to grab that from GitHub because Pablo put that in GitHub. So we need to fetch. Fetch is taking the commits in here and putting them in the repository. Something really interesting. Fetch doesn't touch at all your files. Yes, so it doesn't have a side effect on your files. So it's a completely safe operation. So you can do git fetch as many times as you want, and it will not break your code. So it's important to understand, okay, I can not be afraid of that. Now, we fetch it, so we brought Pablo's changes to our repository, and now we can push. So push is actually the opposite. I take the new things that are in my repository that I created, and I just send them to the repository, yes? There could be conflicts, but the push actually is just moving stuff from here to here. Again, push doesn't change your working copy, it doesn't change your files. And if you didn't commit, you're not going to push anything. So, yeah. What is a pull? So a pull is a fetch and a merge. So it's you fetch new commits, and then you merge what you fetched and what you have in head. Yes? So with arguments, but somebody raised the hand? No. Yes.
Just a small question. I found the name index confusing. Why it's called index?
I don't know. Somebody knows that? Google foo? Okay. I don't know. We can check. Linus was.
It is an index of the files that it knows about, because there are also files that you may have put there that it doesn't know about.
Mm.
Yeah, then you're indexing the files. Like files are in disk, Git doesn't know about those, and then you add them to an index. So it's like a librarian.
Could be, yes. Okay, so now I will let you, Pablo, that will talk a bit about, okay, we have this Git stuff, we just talked about what happens in the command line and in the repository, but when we put this with Faro, well, this makes an iceberg, and well, it has other set of, yes, trade-offs, And you need also a different conceptual model to avoid misconception.
Yes, exactly what we are going to talk is the question that was before is what happened when we add in the picture our Smalltalk environment. And that is what we want to address with Iceberg. So, no, this does not work. So, basically, when we take Git and we want to make it work with Faro, but it's the same for any Smalltalk because we have things in common, we have some additional issues that we have to have in mind and to understand what are the operations and what we are doing. Basically, the big difference that we have is that we have image-based persistence of our code, of our classes, our definitions, of all the things that we have, we keep it in the image. So we keep all the information in the image. In the disk for us is just a consequence or not, we don't need it. We can have all with our .image and .changes and go all over the world with that, and we can be happy because everything is in the image. So we have another level of in this hierarchy. Also, we talk about packages in the Faro sense. We talk about packages, classes, methods. We are not talking about files. So we have a mismatch there that we have to handle. How we take a class that for us is an object, is a beautiful object, and put it in a file or something that we can put in a disk. So then we have Monticello that we have some beautiful system, but it was only for us. And we were like, oh yes, it's us, it's perfect. We don't want to collaborate. And we have learned a lot of concept with Monticello. We have been happy a lot of time using it, but we were in our little island. When we go to the world, it's like it's exactly this kind of movie, the little guy that came from a farm in his little world, and then it goes to the big city, and well, we have this problem. And this is that we have more ideas, that concepts that we have to realign to understand Git.
Yeah, because also Monticello has another commit operation. You could commit code, but commit doesn't mean what it means commit in SVN, and it doesn't mean what it means in Git. So again, you need to align.
Yes, and the branching model and the repositories, and it was distributed but in a different way. So, and interesting, but when we are trying to use Git, because of the reasons that we talked before and many more, we have to handle the difference. So, what is what we try to do with Iceberg? We say 4 things that we manage or we try to push in the metaphor, in the idea. First, that we want to have, as I said before, as all the high-level tools, we want to enforce a path that we know that works and that we can do. This is the same metaphor. You can use it even if you use Git from the command line. Have a path, decide your path, how you're gonna do it, and try to keep that and don't go out of the path. Because if you go out of the path, there is wolves that attacks you. Yes? So that is important thing. And in Iceberg, we try to do that, playing with the toolbar and showing icons and showing notifications on the buttons and showing how to do it. Second, important thing, we need to know in Git when an operation is destructive for us. And this is important, and this is one other of the tips that we want to show is previewing all the time when we are going to do something destructive and ask the user if it's understanding what it's doing or not. Again, you can extrapolate it when you use it Git from the command line directly fighting with the wolf. You know that, as Guille said, the fetch operation does not have danger. I can do it. But the checkout, that might modify my file. So we need to know which we're using. And what that is important in Iceberg, we try to handle that in a way, but it's important to understand that. One important thing is we don't want to have the fatalities that we just copy paste and we don't see how we press the enter because we don't know what we are doing. In Iceberg, we are trying to give we have, when I imagine you have seen this window. When you have a problem in Iceberg, for example, you have a detached working copy, you have that your repository is pointing to something where we cannot commit, as Guille said before. We have different operations to do it. One can be throw everything away and run in circles. We can add it. But we have all of the operations, and the idea is that we want to understand what is it. Again, the extrapolation for using it in another sense is try not to do things that you don't understand because that ends badly. In Iceberg, we added a nice way of using the clear language, using the same concept that we have in Git itself, and trying to reuse them and trying to have a way of having a nice way. This is more if you take the objects and you start trying to do something more, but we love scripting, we love know how the things work, and when we are started working, we will be tempted. And one of the things is that in Iceberg we want to handle that. Show us a clear API and a way that we can extend it. So, what is the main problem Iceberg want to work on? That our image is another working copy. You remember the three, maybe I should have put it, the three elements that we had before, that we have the local repository, the index, the working copy. Well, now we have the image, a fourth in the one. So we have an extra working copy, and our image needs to remember, this is the main task of Iceberg. It remembers the image in which commit it was originated, because it remembers this image, the code that we have in the image is this commit, the DC. And also it remembers, from this commit, I have modified something else or not, or I can see what are the dirty things that are from this commit. But the main work of Iceberg is remembering my image that I have here, that I could have modified or not, started from somewhere. In this case, from this commit. We need to know that because when we are going to pull new changes or we are going to push to the outside or commit, we need to know where we are going to commit or where we are standing to do the next thing. The same when we are going to diff is, did I save or did I commit all the changes that are in the image? Well, I need to compare against something. If not, I cannot. Yes?
I don't know if it changed because I'm still with Flower 10, but actually the case is it's not the current commit, but the last commit there was a code change in Flower.
Is the commit that our code in the image was loaded from. Exactly. Is the commit from because we can only now we will go to the next one. As we have a dual commit, a dual working copy, we can have the problem that, or we can need to have that both are in sync. Yes, because somebody from outside the image can go and commit, change, do checkout, do whatever, and modify the working copy in the disk, and not modifying the one in the image. And the ideal scenario is that we want to work, or we can work happily while we have a sync between the two worlds. That is the thing. Because what happened, and you already, I am sure you have seen it many times, when we have that scenario. I don't know, I go from the command line and I add a new image in my repository, an image, a picture, a new JPG file, and I commit it. And I create a new commit in my repository. I will change the working copy, the commit of the working copy, the head of the working copy we move, but our code is there. So in this case, we have to remarriage this problem, reunify both working copy to be the same. Yes, we can do it saying it twice, but okay, load the new commit that we have there, or we can say, no, well, discard the commit in the disk and go to the, well, all the options that we have in the repair, some have consequences in one side and others have consequences in the other. Yes?
Yeah, I'm just asking because that's opened the whole problem with the external resources. So because you point to your last code commit, and then you change something like Rabbit, like any config files, and then the Flower declines that you think there's a movement.
Yes.
But there should be some kind of fast forward because you have a lot of commits that don't touch the code, and then you avoid a lot of stuff.
Yes, maybe we are needing an operation there that is more clear that is just, but what you can do that is saying in the repair option is, I want to reload the code that is in the repository. Because the problem is, that is a simple one because I can reload the code because there is no difference in the code, just an external resource and just because they are different commits, but the code is the same. But that starts getting more different because I can go and change the files by hand in the repository and commit and well.
Yeah, so in that the worst case, we need to do a diff between this guy and this guy to see, did you change any code?
Mm-hmm.
But you can just, like you said, right? Discard whatever is in power and go to the
Yes.
version. I always do that.
Yes, you can do the three options, or there are more options, but basically you can discard what is in Faro, even if there is changes in our image working copy. We charge everything from the disk. You can discharge what is in the disk, or you can try to merge them to be happy. Like there is different. You have to understand the key here is that you have to understand that you have two things and you have to put them in sync. Yes.
Discarding changes on the disk means checking out another commit, right?
Yes. Okay. Again, with the possible loss of those changes, and yes, maybe half a day of working.
It may not exist.
Yeah. Yes. We have to understand that what it means. In this case, is exactly removing the change from the disk is okay. I will go back to a previous commit and.
Yeah, because also you have to think that you could have done everything perfectly and work in the command line and commit, but maybe you were a bit messy and you changed the stuff in the repository in the disk directly, and you didn't commit. So should Iceberg lose your changes that you didn't commit? So there's the answer is no. Iceberg shouldn't. That's why for now the current version is a bit defensive to try to avoid losing changes for you. Yes. We can optimize later, but.
Yes. Well, we say that it's rare that happens, but we have the detached working copy, maybe less rare than we said in the slide. But basically, it happens when you touch your Git repository from outside, but also can happen when we commit, we are only using Faro, we are happy, but we have a crash or we don't save the image pointing to the new commit. So we can do that. Okay. We modify our code, we create a new commit, but we discard the image, and then, when we open the image again, it remembers the previous one. So it's not something that I have done wrong. Maybe it's something because as I work. Okay. As I say, how do I get out of this situation? Well, we can move the image to the state of the repository, that basically is load what is in the disk. We can change the repository, what is in the image, or merging them in the thing. But we need to understand what we really want to do. So, as you see the idea, we just introduced some context. The idea now is to be more open. We can talk and do discussions. I don't know, you created the pad or not? Okay, I can create it here. The important thing is Git is a powerful tool. Yes, it give us a lot of power, but we need to understand in which context we are and what we want to do. Yeah? You need to know, not the internals, here we say we need to know the internals, but you have to have an understanding of what are the basic ideas, like for example, with what happened with the commit, how they are organized in a graph and reference, and this idea of the working copy. There are other concepts that we passed by. They say, okay, no, we are not going to talk about that. So there are more concepts, but you can, or we can live happily without that, and we can start adding it slowly when we are mastering the ones. We can add like, for example, staging changes, or how I move changes from one branch to the other. Well, that you want to is more advanced, but it's based in the same idea. So starting from here, continue reading and going up in the stair of knowledge. Yes?
Do you have the ability to look at differences between two branches of code?
Yes.
Why those differences to you, just the differences?
Yes. But when you, I will show you, I don't have a specific, but when you are loading, for example, code in Iceberg, or because basically something that we have to do in any tool, we are loading something or we are checkouting, we should not do the things blindly. We are showing the difference with for example, this is in the side is the content of a commit, and the other on the right side is the difference what you have in the version that you are loading with the image. So that is the changes that will be applied. And I don't know if it's seen. I have here. Sorry, because I should have prepared another image, another picture. Here it says what to do when doing the checkout. In this case, it says we are going to check out all packages that are already loaded in the image. So we are going to import the changes that we have. There is a second option that is we are going to load all the packages, because in the repository can include new packages that I don't know, I create a new class, I put it in a new package, I commit it in the same repository. So when you download do a checkout of my version, you want maybe to load that package also. And there is a third option that is I will not do nothing. Do the checkout in the disk, but my image is my image. I will handle it manually later.
Okay, so to be clear, if there's branch 2 and 3,
Yeah.
there's a difference between I can apply those changes to branch 1.
I should remember the operation of merge is always is I am in branch 1. I will bring the changes from branch 2, and then I will bring the changes from branch 3. Okay. The merge operation is always I am in a branch and I will bring changes from somewhere.
Because the reason behind that is that any merge can create a conflict, and you need to resolve that conflict in some working copy. So that's why you need to check out usually the branch where you're going to do the merges. So like that you have a working space, you make your working space by checking out, then you merge, you solve conflicts if you need to, and then you...
Yes, and then you merge the third time, fourth time.
Because if you try to merge things that are not in the working copy, if you have a conflict, you cannot. Maybe that could be a fast path, and then if you have a conflict, you can fall back to the others. I created a path, I shared it into the off-topic thing in Discord, in the Faro Discord, in the off-topic channel. I also shared it through WhatsApp. I shared it to you, Pablo, on Discord also. So the idea is to grab, if you have questions, and if you want to make a short video on something that is maybe complicated, maybe you can put your ideas there. We are going to grab them.
Okay.
So
yes,
maybe
and
you can, I don't know if people want to go to it. Maybe we can solve some of them now.
yes, but I don't know how much time we have. Yeah. Okay.
Yeah.
Okay. So.
You have to present now? No, after lunch. Yes. No, but yeah, we are hungry, right?
So.
Yeah. The next one on this session is the food. I'm sorry, no telematics.
So is the Discord also, if you have like bugs in Iceberg, this is where you should send them?
In the other,
Del foco.
Oh, the GitHub issues.
yes.
Oh, okay.
What?
Yes.
Yes. So if you have something that we want to push now,
I know. So my question is, so you say that
No, but
you have two working copies.
yes.
So whenever you do a commit with Git in the file system, you get created this IDs DC or something. Whenever you add a method or save a method in the image, something similar happens.
You need an explicit commit operation. So it's like you have to open Iceberg and say, look, I have these changes that you made. You added this method. Do you want to commit to the repository? You click on commit. It's like writing git commit from the command line. And then that actually updates Faro, so the working copy on Faro, the current commit, and also the repository, the working copy in this, and everything. And so it has to...
Pharaoh's VI.
Huh?
Pharaoh is VI. If you did it on the disk, you make changes to your working copy and you see diffs.
Yes.
You do it in Pharaoh. Pharaoh is got its own working copy, and when you save an image, it's a VI editor. That the moral equivalent of that.
So it's like in Faro you are also maintaining the same index that Git is.
So we talk to Git and we collaborate really tightly with Git and we say, okay, with Git, what is your index? Git, put this in the index, please. So yeah, we talk to Git, we work.
Sometimes. It's like friends. Sometimes we are not so.
Really good friend.
Yeah. Okay. Nuri have a nice question here. It says, can I have a symbolic link branch? The idea, I think, is that having something that always point to the its release. So let's say, okay, my version for Faro 11. Correct me, Nuri, if I am saying it wrong. So the idea is that any of the users can always put to Faro 11 and then move when you do a new release, you move that. And the answer is yes, you create a branch.
Yes.
How to evolve it?
But in,
Ah.
in Git or you're talking about Git or Iceberg? Because here you can put expressions about Git also. So
Okay.
not the same answer.
It's, my target is iceberg, but
Hmm.
if I cannot do it, I can fall back to Git.
So
It's do we have it in Pharo, for instance?
no, we don't have.
Hmm.
Actually, I think that having somehow
Something like that.
this could help in this fast-forward idea that Norbert was saying to help people solve the detached get the detached
Faster.
issue.
So the other way to phrase it would be, can I, when I add a tag, can I change it? Say, okay, no, the tag is not this commit, now it's the other commit.
Yes.
Well, yes, you can. Git will, so by default, Git will not do that. So Git says, okay, tags are references that don't move, so and branches they move, so you can branch and moves around. You can move it, but it's not recommended.
Yes, and
Not in a good path, my good.
yes, the tag should not move, and in the recommended way, the branch should add commits. Never, let's say, you can take a branch and make it point to something completely unrelated, but that will make unhappy the users, because if I already check out your branch pointing to, I don't know, the commit A, and you make it commit now point to the commit X that is completely unrelated, I will never be able to, without doing a fatality, to pass to the, I cannot do pull here and go to X, because our histories are completely unrelated. So yes, and so in this case, I will use a branch, because basically something that should move. And what I will do in the release process is that while you are adding commit, is sometimes adding a commit. And what we do for doing that to support backporting changes is that we keep let's call it release branch for a version, for Faro 11, a release branch for Faro 12, and then we have a development branch for Faro 11 and development branch for Faro 12, if the histories have split. If not, you just are moving the same commit. If you are just saying, okay, up to here I do the Faro 11 support, and well, you create the branch up to where you are and you continue committing in the future, and it's okay. But yes, for releasing, it requires, or you force your users to use a tag and say a specific version of you. Wing. The roadmap in Iceberg. That is easy to answer. We are trying to do cleanups and improve the usability. So every time that we try to do something, there is no a big set of changes that we foresee in the future, but the idea is to add more operations in the sense of the repair action, and also clarifying. Steph has done a pass, for example, clarifying the text and clarifying the name of the options to make it more clear what they are doing, what they are not doing, what is expected to do. That is more important than it looks like, because we need to, as I say, give the users knowledge.
But to give also another, maybe the more political answer to Arturo. So given the huge amount of features, well, first, if, for example, people want rebase, I will not implement it because I am against it. So you should not rewrite the history. So that is my personal take on that. So, but I accept pull requests. So that is my base situation. Then we can discuss. But
I was asking for interactive relays.
yes.
Yes.
Exactly. So no, I will not. I hate rebase. So the problem is that as soon as you put rebase, everybody, what we try to say is do rebase and you mess things.
Miss history.
Do it by the command line, so why would you implement it? There's always a way.
Yes. So if you want to do it, do it. I'm not against that. So you're free to do whatever you want.
But it's true that the merge will be better. Nicer.
No, but the problem is that then people will say, erasing this block, that is the bad thing, and then actually, yeah, you're rewriting the history, and if you're working in a team and you're erasing, you're actually breaking each other's branches and repositories, so it's, so there is a question here on how do we work on a PR when the project got more commits? You check out the branch of the PR. So by the easy answer is that you check out the branch of the pull request and you work on that. If you are working on Faro, that's a different thing because updating a live system is not so easy. So there is a different workflow that doesn't fit in the minute. I cannot explain it. But just when you're working in normal pull request, so check out the pull request, work on that, repush to your branch.
I have a workaround that ended in 10 minutes, in 1 minute. That is what I do. I keep the image until the pull request is merged. I create an image, I work on that image, and I keep it until somebody merges it, and then I delete.
There are videos on YouTube about the full cycle. So somehow.
Yes. But
we can put a video if you want. Okay, yes. You go?
No, they go.
Okay, so first, behind the scenes, we talk with this, I said, we talk with Git, we are friends. Actually, to do that, we use a C library that is maintained by other people that is called Git, that is not feature complete. So it doesn't have all the features of the actual Git that you use from the command line. So for example, it doesn't have a shallow clone. Yeah, so you cannot do that. I don't know if they're adding it in the next versions, but there's, for years there has been an open issue in the Git library. It's a library that is used by many other people. Like, I think that Visual Studio Code uses that. There is a way, so at some point we had a backend. Where is Dimitri? So there was a backend that was using Bash. We kind of dropped it at some point because it was easier, it was faster, and we didn't have to maintain a parser of the outputs of the command line. It could be implemented. I'm not planning it personally. If you want, we can talk. Something else? Yes, real time.
So maybe I did something wrong, most probably, I don't know. But I'm committing a lot and pushing a lot because I've always feared to lose the stuff. So you see my package, in my package I do a lot of extension to the integer class.
Yes.
And the last time, like last week, I was merging my branch with the feature for here to the master, and I lost all the extensions.
Are you using for 12?
11 stable.
So first, it's software. I don't guarantee that there are no bugs. I don't guarantee. So but if you have a reproducible way to have the problem, so if you can reproduce the problem, we can probably debug it and fix it.
Or yes. Or also, if you, this is a note that can work for everybody. When you have a problem with Git or Iceberg, or tell us, I have this problem, if you can give us the commits, that is excellent. Because, for example, not needed to have a reproducible that you do it like this, but as history, Git already keep us the history. If you tell me, I was in this state, when I merged this commit, it generated me this third commit, we can see what, or try to infer what is the problem. And also, there is some reproducibility. So if we take the two commits that you merge, it should have the same conflict, for example. So that's nice.
If you tell us, I was in this branch, in this commit of this repository, and I checked out this branch that was in this commit and I had the bug, we can reproduce it. So. Yes, sorry.
From an implementation point of view, are you,
Yes.
are you decomposing to some ST files, or are you actually doing introspection on the classes when you do these comparisons? Does that make sense?
So,
Like,
Maybe I
from
understood.
the implementation point
Yeah.
of this, how are you doing it? Are you just making a text file and doing comparison, or are you actually introspecting on the
no,
classes?
actually we partify with an AST and we compare from the an AST point of view. So we don't do line per line diffs. We do so it's a bit more intelligent. We say, look, there is this method here that was actually in the other version is here because you have the stuff in the middle, and we compare methods. Then. So we can compare. Otherwise, Git sometimes it gets confused. So we parse the files, we beat the trees, and when we dig the trees. So it's kind of the equivalent of a merge driver that you would implement in Git, but we implement it in Farm.
Thank you.